my name's Deborah Fowler, and I'm going to talk about using Vex to populate a wall with windows. So what we're going to do is use a Wrangle node to calculate the number of windows in a given space that will fit with evenly spaced gaps in between. So let's get started. Right now I have set up a few nodes, just a simple parameter control here for the width. In here, if I dive inside into my container, I have a box, which is my pseudo window, and my wall, just a grid, which is being controlled by the width. And this is just an arbitrary size that I chose. We could make these controls later, and I've merged them together. What we're going to do is we're going to create a point wrangle node. So point wrangle nodes use Vex expressions or Vex snippets, which is a subset of Vex. And Vex is a language that you can use in Houdini. It's very powerful. So let's get started. Right now, a point wrangle uses points that we feed in, but we can also change the setting and say detail only once. And what happens then is this point wrangle then becomes able to give me a point. So I can call a function called addPoint, and let's just give it some coordinate, say 15 in y, and in that. And now we have a point. Now right now we can't see it because it's up a little high. Let me just turn up my geometry display so we can see the points a little better. Got my origin on so I can see it there, and you can see that that point is wherever I happen to put it. Okay, so that's great. Let's figure out, how do we fit windows across this surface? So there's a few things we need to know. First of all, we need to know how big is the window. So I'm going to go ahead and reference box 1 size X, because that's representing my window. Second thing we need to know is the wall. Well, we could either just reference the width, or we can say grid 1 and then size X. We're going to add what I'm going to call a space adjust. I'm just going to make it local to this Wrangle node right now. So if I just add space adjust here, I can always reference it at the top level later. What I can do in a Wrangle node is use this little button over here to create that parameter. So right there I have space adjust. I'm going to just put 76 in here, 0.76. All right, so that's just going to be the space, approximately the space I want between the windows. Now my windows are set size, and we don't want to take fractions of the window. We're going to have a number of windows, and they're going to have some space in between them. But even that might not fit evenly, so we're going to have some left over. So we got to figure out how to distribute that leftover space across the gaps in between the windows. So the first thing we're going to do is figure out how many windows can we have. Well, I'm going to call that winFit. And that's going to be an integer value based on the length of the wall divided by the window plus whatever space I've decided. Okay, and then I'm going to calculate what's left over. So what space is left over once I put those windows on there? So if I take the wall and subtract off the number of windows times the window size, how much space is left? Then I'm going to take that as my gap, and I'm going to say leftover divided by winFit plus 1. Now why plus 1? Well, if you think of having 3 windows across here, say, and I have them populated across, let's go ahead and do that. Just going to go ahead and add a copy node so you can just see what I'm talking about. So let's say we just took that window and we take 3 windows. Let's do 3. In between we have gaps here and on the outside on the both ends. So we have 1, 2, 3, 4 gaps. So 3 plus 1. Same thing with 4. We have 1, 2, 3, 4, 5 gaps, and so on. So that's all we're doing here. All right, so back to here. we have our gap, which is leftover space after we've smushed all the windows on there. How much space is left? We're just saying, okay, the gap then is the leftover space divided by window fit plus 1. So in other words, the number of gaps that are going to appear. So next, we're going to define a position for that. So we're going to need a few things. I'm going to need a start position, which I'm just going to call start, which is just going to be half the wall. So I'm going to go in the negative x direction, half the wall times 0.5, or divided by 2, whichever you prefer. And then I'm going to define an x value. Now I'm also going to define a location, and this location is going to be a vector. Now technically speaking, I don't really need this, it's just convenient. I'll show you why. If I say xval in here, it will give me an error because it doesn't like that syntax. But I can say set, there we go, and that works. Now right now it's giving me a warning because I don't have any value in xval. It says uninitialized variable. If I just create, say, equals 0, then it's all happy. Okay? So this value is going to control where my window's placed. Now let's actually set up the copy to points in here as well. And we're just going to wire in the point wrangle into there. Wire this in, get rid of this since we don't need that. We don't need that. And right now you can see, I'm just going to tidy this up, flip-flop those. And you can see now that we have our window sticking on top of wherever we put this point. So if we move this point over to 5, it's going to go over there, right? Let's get rid of that 7 in there because that's kind of distracting. And I'm going to change this to location because what I'm going to do is I'm going to just use this so it's just easier for me to read. Not a big deal, again, not necessary, but I'm less likely to have a typo or an error if I do that. Okay, so now I have my point. And this is just my value of where I'm putting that window. Okay, so let's actually create more than one window. To do that, we're going to do a loop. The syntax is very C-like for int I equals 0. I less than, well, how many windows? Well, we calculated how many would fit. We're going to increment I. And then the body of the loop is defined by these curly braces. So that I'm going to indent inside of there so that we have a clear line between these two curly braces. Now, Vex does not require that, so unlike Python, it doesn't care about indenting, but people reading your code do. Okay? So I care. All right, so let's start off with the window at the start. So what that does is it moves it to the left of the origin. So we're here at X, it goes half over here. Then the next thing we're going to do, so it's not sticking all over the edge, is the windows are centered on their local little origin. So we're going to multiply by half the width of the window. So now we're sitting on the left-hand side. Perfect. Okay. But we have gaps in between. So the first thing we need to do is we need to add a gap. Now, for all our windows, though, we're going to multiply by how many gaps have appeared before. Well, it's the first one plus all the ones in between, so it's going to be I plus 1. Now, we also need to take into account the window size. And how many windows have appeared before? Well, that's I. So you can see now we have our windows populating our space evenly. So if you look at this, you can see that the spaces between those windows are even. Awesome. So we now have a nice little control that we can place windows onto a wall. So if I change the width, you can see that things are still working. If I go in here and change the space, if I set it to 0, I still have a gap in there. And that's because these windows are a certain size. So in order for them to fit evenly, I would have to have exactly the number of windows times the width. So in this case, 30 would make them fit perfectly evenly. If I have slightly more, I'm going to get a little gap, even though I have space adjust. This also allows me to put spaces in between if I decide that I want it more static and I want to have a little gap, or maybe even a huge gap, right? So essentially what it does, it allows me control of where I'm putting those windows, but always providing me with even spacing should I want it. So this is how we populate windows onto a surface, or whatever it might be. It may not be windows, it might be some other object. Okay, so next let's modify this to have a door. But before I do that, I wanted to mention that Vex is not the only way to do things. It's just very cool. There are other methods, and before Houdini 13 we didn't have point wrangles or wrangle nodes. So what did we do? Well, we had Vex we could use. We could also use the HScript language, Python, and so on. Here are some other methods. This was a file that you can access on my website under the tips and tricks for Houdini. There's also a file that does all the different configurations for doors, various wrangle node configurations, which I will show you and point you to that. We're going to go through one where we're going to fit a side door on. However, I wanted to show you this briefly because I think it's interesting. This is exactly what we've been doing so far. It's essentially the equation for creating a evenly spaced windows, and that is sitting right here where we're adjusting the size and so on. We just went through that derivation. What I wanted to show you is the functional equivalent in HScript. So this one is using HScript expressions, and that was another method that we could use. And you can see I'm getting nicely evenly spaced things on here. It looks very similar, but this language is not as fast as Vex, and it is not as well documented. So if you look in here, I have a expression where I'm calculating how many things are, how big is this, how many things can fit based on the size and the spacing. And then I'm moving them very much like we did in the other example. I set up my window, and you can see the syntax is a little unusual, but it's still equivalent. So this is still a viable option. This is HScript. But I would strongly encourage you to use Vex instead. But I kept this for completeness. Up here I have a couple other examples. So this one is copy on curves. So what we do in this case is we're simply using a curve. Now you'll notice these aren't evenly spaced. We've got this extra space on here, but that's simply because of the way that we're doing this calculation. So we have a length, which is just our grid size. And then in here, we're just taking that size and dividing by some value, which is the window, plus some space. That gives us a line with points. But if we just copied that onto our windows, copied our windows onto that, what we do end up with is windows sticking out on both sides. We don't want that. So what we can do is take a delete node and simply delete the first and last elements. So that's what I'm doing here. You just see later use a point wrangle node for much the same thing. So that's another option without using point wrangles. And this one as well is using HScript, and again I've got these controlled by the same thing so you can see it. Again, they're spaced in between the windows is even, but if there's a leftover part where there's just not enough room for another window, that goes on both sides. So if you look at the calculations, again, this isn't HScript, it's another language that Houdini speaks. And you can see the expression here. I'm going to the left, and then I'm populating based on the 5 comes from the fact that I am essentially doing here 3 plus 2. That's the length of my window plus whatever I wanted for a gap. And then I'm just taking what's left over and putting it on both sides. So that's what's going on there. So in my opinion, point wrangles are the way to go. So first of all, let's start with a door. So I'm just going to bring down a box. In fact, I'm just going to borrow this box. And I'm going to make this door so that it is sitting on the ground plane. I'm going to copy this reference and paste relative reference and multiply by 0.5. And this door is probably a bit wide because I don't really want a wide door. I probably want it a little taller. And maybe let's make it slightly different. Okay, so now I have a door. Great. I want to make it a little different size so that you can see that this is all working. Okay, so let's go back into our point wrangle node. Now what we have here are the window and the wall and so on. So let's add another variable for our door. And again, reference that channel. And it will probably be a good idea if we rename those, but for right now I'm just going to leave this as is. So now we have the door size. What we want to do next is, rather than trying to fit the windows through the whole wall, which we need to find room for that door, I'm going to define a space for windows. And that's just going to be the wall minus the door plus whatever I decide to have for the spacing. So again, we're just going to use space adjust. And that's going to be what we have left over for the actual windows. Okay, so all we need to do is change our window calculation to be space for windows. And that gives us the number of windows we can fit. But there's one other thing we need to do, because that's the number of windows. However, we also want to have the number of objects that we want to put in. So in fact, what we're going to define, we're going to use this for convenience. We're going to call this geometry fit, and that's going to be the windows that fit plus 1 plus the door. Okay, now I'm going to show you why in a moment. Okay, so remember that when we were dividing the gaps, we were dividing by a value that was window fit plus 1 because the gaps are on both sides. Well, now we also have a door, so we need to add not just this, but also a door. So that becomes another piece of geometry. So really 1 plus 1 is just 2. I'm just going to make that cleaner. And then I'm just going to replace this with geofit, because that's the gap that we're going to calculate. Okay? And this is also going to be forced to be a float, just in case we have an integer value. I don't want an integer divided by an integer, because sometimes that can result in an integer. Okay, so now we're pretty much set to adjust for our door. What we can do is, for this particular house, the door is going to be on the left. So I'm going to go ahead and change my window settings so that I am going across for that very purpose. So I'm going to start, but then I'm going to add the door plus a gap. So now I've moved my windows over, but you can see that there's a problem here. Well, it's because I'm still calculating with only regarding the leftover being the wall minus the window fit. So I need to actually add also the door, because that needs to be based in that calculation. And now we can see the windows are much more at the way I would expect. Okay, so we now have the windows fitting. Well, what we're going to do is, since there's only one door, we don't need a loop, but we do need to make a point for that door. So where does that door start? Well, that x value for the door is simply the start plus a gap plus moving the door over by half its width, and that will put the door in the right place. So I'm going to go ahead and assign the location to be set to that value, and then I'm going to add a point, and that's going to be 0, location. So I've just added another point. Now right now it's putting a window on there because we're doing this in 1 point wrangle. So what I can do is I can simply get rid of that point. And it's the last point I added, so I know it's going to be the last point. I throw down a delete node. So let's go ahead and do that. And let me just make a little more room for this so that we can see what's going on. Okay, so here's my point wrangle. And what I'm going to do is delete a point. Now if I turn this to points, it's going to delete whatever I put in this expression. So I'm going to say at point num, if that point number is the last one, which is just num point minus 1, if that's true, then I want you to delete that point. You notice our windows now are not going to that space. That's what we're reserving for our door. And now what we're going to do is take the complement and copy this door onto that point. So I'm going to take a copy to points, And I'm going to wire in, instead of a window, I'm going to do the door. And instead of, and we're starting to get a little messy, and so instead of a delete from here, getting rid of the last point, what we're going to do is take the complement, delete non-selected. So this leaves us with the points for the windows. This leaves us with the point for the door. So we can then copy that into our door. So we have our door. Let me just tidy this up a little. We have our copy to points, and we have our door going on to that point. We have our windows going on to there. Let's just adjust this a little so that we have our grid at the first, so it's out of the way. And now we have our setup with our window and our side door. Now right now it's kind of scrunchy together, but that's because our spacing, we left at 0. Let's increase that spacing a little so it looks a little more like you'd expect. Okay, so again we go back to the top and make sure that we test our controls and make sure that everything is working, and we can see that it is. So that is an adjustment. So you can see how easy it is to manipulate these point wrangles to get the information that you need. So taking a look again, let's just take a look at that code. All we did was modify it slightly. So we added a door, and that door has a size. We subtracted that door off the space that's available for the windows. We also got rid of the leftover to be the entire width or the entire size of the wall minus how many windows would fit plus the door. We recalculated the gap based on how many objects we're going to be using this gap. Right? So again, we're just assuming it's an equivalent gap along all of them. Then we simply move to our correct position and populate our area. In this case, it was easy to just add a point for the door, and that works. You could also have had other requirements. So let me just pull over this file here. This is from my website, my description here on Wrangle nodes. So in here, there's Wrangle node example with window calculation. It goes through the derivation, and it talks about what's going on in description. And right at the top, if you click on here, there is the file that is being viewed here. Okay, so in here, we've just gone through this. This is just the side door, right? So we have more controls. We've got width, depth, testing out, making sure everything's working before you go any further, door size, and the amount of spacing. Okay. Now that's one situation. Perhaps you want a door so that it's placed with the windows equally, but you also want a gap for that door. So in this case, we've made it so that we can adjust the door, spacing, window size, depth, and again width. Again, it depends on your situation. In here we have a side door with doors placed and then windows. So again, there's many ways to do things. This particular example in here is doing this a little differently. Okay, so again, it really depends on how you want to set it up. This is a side door with some gap. And now I'm using different methods. So in here, if you dive inside, you can see that I'm not using a point wrangle. So again, I'm using a line. These are various methods which, if you're interested and don't want to use point wrangles, you can use as well, quite easily. So I hope you enjoyed that, and I encourage you to learn more about Vex. Thank you.